Greetings, intrepid explorers of the cosmos. Have you ever wondered what would happen if you could travel at speeds approaching that of light? Today, we are embarking on a profound journey into one of the most astonishing concepts in modern physics: time dilation, a phenomenon where time itself becomes relative. By the end of this discussion, you will understand the intricate mechanisms behind time, slowing down for those moving at extreme velocities, and discover the incredible implications for potential interstellar travel. Our adventure begins with Albert Einstein's groundbreaking special theory of relativity. Introduced in 1905, before Einstein, time was largely considered an absolute, unvarying constant, ticking away uniformly for everyone, everywhere. However, Einstein fundamentally reshaped this understanding by postulating two revolutionary principles. First, the laws of physics are the same for all observers in uniform motion. And second, the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source. From these deceptively simple postulates arises a consequence that challenges our everyday intuition. Time is not absolute, but relative. Time dilation means that a clock moving relative to an observer will appear to tick slower than a stationary clock. It is not an illusion. It is a real physical effect where less time truly passes for the moving object or person. Imagine an astronaut embarking on a journey at a significant fraction of the speed of light. Upon their return, they would find that less time has passed for them compared to their friends and family who remained on Earth. This is sometimes referred to as the twin paradox, though it is not a paradox at all once one accounts for acceleration and deceleration in a complete relativistic framework. But how does this happen? The core idea lies in the constant speed of light. Consider a thought experiment with a light clock, which measures time by a pulse of light bouncing between two mirrors. If this light clock is stationary, the light pulse travels a straight vertical path between the mirrors. Now, imagine this light clock is moving horizontally at a very high speed. For an observer watching the moving clock, the light pulse must travel a diagonal path to reach the mirrors, covering a greater distance. Since the speed of light is constant for all observers, if the light travels a longer distance, it must take more time according to the stationary observer. Therefore, the moving light clock, and by extension, all processes within the moving frame of reference, appear to run slower. This phenomenon is not merely theoretical. It has been rigorously proven through numerous experiments and observations. One of the most compelling pieces of evidence comes from particle accelerators, where unstable subatomic particles called muons are created. Muons have an extremely short lifespan, typically only about 2.2 microseconds. However, when these muons are accelerated to speeds near that of light, their observed lifespan dramatically increases. Scientists observe them existing for much longer than 2.2 microseconds from the Earth's frame of reference, precisely matching the predictions of time dilation. This relativistic effect is not some obscure scientific curiosity. It is so pervasive that it must be accounted for in everyday technology, most notably in the Global Positioning System, or GPS, without correcting for both special and general relativistic effects. GPS satellites, which orbit Earth at high speeds, would accumulate errors of many kilometers per day, rendering the system useless. So, if time dilation is real, does this mean humans could use it for interstellar travel? The prospect is tantalizing. If a spacecraft could reach speeds very close to the speed of light, the journey to distant stars would feel much shorter for those on board. For example, a trip to a star system 100 light-years away would take 100 years for an Earthbound observer. But for astronauts traveling at, say, 99.999% of the speed of light, the journey might subjectively take only a few months or even weeks. However, the challenges are immense, perhaps insurmountable with current technology. Accelerating a spacecraft to such extreme velocities requires an astronomical amount of energy. Einstein's famous equation, E equals mc, demonstrates that as an object approaches the speed of light, its effective mass increases dramatically, requiring ever-increasing energy input to accelerate it further. Furthermore, the cosmic environment at near-light speeds is incredibly hostile. Even tiny dust particles would become lethal projectiles, impacting with the energy of high-speed bullets. Developing shielding capable of protecting a spacecraft and its crew from such impacts is an engineering feat far beyond our current capabilities. The energy sources required to achieve and sustain these velocities are also currently purely theoretical. We do not possess propulsion systems that can provide the necessary thrust and energy efficiency. Could future breakthroughs in physics, perhaps involving concepts like warp drives or wormholes, offer alternative pathways to circumvent these limitations? While such ideas are currently confined to the realm of science fiction, the history of science teaches us that today's impossibility can sometimes become tomorrow's reality. Ultimately, time dilation offers a fascinating glimpse into the true nature of spacetime and the potential for humanity's future in the cosmos. It tells us that time is not a fixed universal drumbeat, but rather a flexible river, flowing differently depending on one's motion. While the practicalities of near light-speed travel remain formidable, the theoretical possibility ignited by Einstein's genius continues to inspire dreamers and scientists alike. Understanding time dilation deepens our appreciation for the elegant and often counterintuitive laws that govern our universe, pushing the boundaries of what we conceive as possible. What are your thoughts on time dilation and the future of interstellar travel? Do you believe humanity will ever achieve speeds close enough to light to experience significant time dilation? Share your insights and questions in the comments below. If you found this journey through space-time enlightening, please consider giving this video a like. Subscribe to Space Repo for more explorations into the wonders of the universe, and join our community of cosmic enthusiasts. Your support helps us continue to unravel the mysteries of existence. Thank you for watching, and keep looking up.